to you about a research project I'm currently working on. It's an ongoing project. It's entitled Disseminating Stonework Conservation Practice in Edinburgh, and it's supervised by Dr. Kessissoglou and co-founded by the University of Edinburgh and the Edinburgh World Heritage Trust. You're probably already aware of the Care and Conservation of Georgian Houses manual, in which the authors some decades ago recorded and disseminated good practice through their experience in various successful conservation projects. Our project is inspired by this approach and intends to use the experience already acquired through recent projects for training purposes. More specifically, examples of good practice are here recorded, and conclusions are drawn from past inappropriate solutions, and the complexity of various technical and theoretical issues is highlighted. We aim to raise awareness on the importance of good maintenance and to offer hands-on experience to training masons, designers, and professionals, as well as homeowners, in an attempt to help with this problem that is already being discussed and Joe already told us about, that there aren't many appropriately qualified stonemasons and craftsmen in general. How we're going to do this? A, we're making a scale model, a physical model, and B, we'll be using some digital technology as well, some three-dimensional drawings, and possibly video. The model will be transferable and easily assembled, and is assembled in order to encourage innovative learning through action, reaction, and observation, which means that the final model will be pretty much like the one you can see at the other room, but people will be able to remove some parts and see what's inside and how all these things put together can form a whole. We are collaborating, as I already said, with Edinburgh World Heritage Trust, various architects and other conservation bodies and professionals who have provided us with past examples of successful conservation practice and who have shared their experience and in-depth knowledge on the pathology. The problem we're focusing, I haven't yet mentioned it. It's a part of the roof of neoclassical buildings, and more specifically, balustrated cornices and parapets. There is a certain methodology we're following. First, establishment of the problem. There are various. We chose to focus on that area because there are many common problems that have appeared in various projects that the Edinburgh World Heritage has funded. Next step is simulation of available key solutions. Due to the fact that there are many different detailing and architectural decisions that were made in the past to buildings that you would think were built in exactly the same way. Many different solutions have been applied, and many other solutions currently could be applied to answer same issues. They are different in each case. Then the third step is an interim assessment, where we actually present our findings to all the stakeholders involved, and we get some feedback so that we can improve how we're already going on. And then we go to step number 4, which is the model fabrication. And then the last is the evaluation with the partners. As we can obviously understand, we're still at step 4, and actually 4A, which is the testing model fabrication. The problems we've identified after discussions with the project partners, the most common of them, you can see them on the drawing. A classic, very typical problem is the gutters overflow, the water penetration to rafters and roof in general, the deterioration of the stone, and the erosion of the pins, and finally deformation. After many discussions with different people, I've come to realize that there are many different approaches, and this doesn't necessarily mean that one is right, one is wrong, one is appropriate, and another one is not. It might be just a different philosophy towards conservation in general. Of course, it depends on the degree of erosion that we have each time. It depends on the cost and how much funding is available, on the time schedule that we have for a project, on the available material, and of course on how different architects, what they think about original material reuse. And I'm mentioning all this because if we take, for example, the replacement of balusters on a roof, we can see on the left side the example of a case study where it was decided that only the capitals and the bases of the balusters should be replaced as an effort to keep as much of the original material as we could. And on the right side, we see that whole balusters were replaced. The argument here is whether it is worth it to keep as much of the original material, or whether it's not that much expensive to replace the whole baluster and have a more unified result and less joints, so less possible future erosion. The scale of the model was a very important issue. We have decided to scale 1 to 2 because it allows us to show clearly some construction details we wanted to focus on. And it also gives a good idea of the original dimensions. As we wanted the model to be portable, you can understand that it wouldn't be very smart to decide the 1-to-1 scale, but the 1 to 2 is a quite good decision because it gives an idea of the weight, especially the cope or each of the balusters themselves. And it can be still transportable to training institutions or probably the Edinburgh World Heritage where they can show it to homeowners. The materials is also another issue. We decided timber was to be used because it has a substantial weight. It allows quite easy transportation, and the details can be shown very clearly. It can also be easily worked with the equipment that we've got at the workshop downstairs. We have used a variety of hand tools and computer-controlled machines to achieve the desired results. Plus, it was very important to have advice from experienced technicians so that we can save time and avoid mistakes. And we had the chance to realize the advantages and restrictions in the use of each tool, machine, and material, which was very important during the fabrication of the model. It was very important to get everything together before starting, to have some extra material in case mistakes were made, make a plan, and generally manage our time wisely. Of course, there's always the question, maybe I'm showing too much information here and maybe we lose the point. So we had to decide to show some things and to avoid showing other things so that it doesn't get very complicated. And sometimes we had to revise our original ideas. For example, we didn't do the whole out of timber in the end, but we also used plaster, as you can see, to cast the balusters, and we made a specific mold out of silicon to help us fabricate more balusters out of the same mold. That's our experimental model, and that area highlighted in purple is what we intend to show in the final one.